Hi everyone, good morning. Today is, I haven't projected my screen yet. So let me project my screen. This one. Okay. All right, yes. So today is Friday, November 17. So today we will finish 6.6 and we will also talk about the quiz 5 solution and MA6. Next Monday, we will talk about session 7.1 and you will have homework 9 and quiz 6 due next Monday. Okay, everybody, when is our exam for? The Wednesday after the Thanksgiving break. And also your homework 10 is due the Friday. So, by the way, the homework due date is there. So I just want you to submit your first attempt by that time. So I can see you did something on your homework. So even though it's after the homework due date, you can also open a second attempt to work on the problems you got wrong and improve your homework scores. Okay? So the due date is just you submit your first attempt by that time. Okay, and then after the due date, if you want to improve your scores, you can continue to work on those problems. Okay? Yes. But the absolute deadline for all the homework, practice exams, exam correction and record is the Friday of last week. Because over the weekend, I will calculate all your scores. And then after I calculate your scores, I will email you and have you help me to check the scores. If you're okay with that, then see our final exam is on Monday. And hopefully I can finish grading your final exams and then I will post your grades on Tuesday. Yes, so that's our plan. Okay, so yeah, let's talk about the quiz 5. Or maybe let's wait for like more students come in. Okay, let's talk about the quiz later. Okay, how about let's go over the 6.6. So this is the last session of chapter 6. Okay, so after this session, that's everything on your exam 4. Your exam 4 covers 6.1 to 6.6. So applications of derivatives. All right. Last time we talked about tangent line. Do you remember? The point is a f of a, and the slope is f prime of a, right? And with the point with the slope, we can write down the points of form. And when we solve for y, we both sides add f of a. Therefore, the tangent line is f of a, plus f prime of a times x minus a. This is the tangent line. So, the idea of this session is to use the tangent line to approximate the function. For the tangent line, you can see here, you get a number plus another number times x minus a. Do you see it only involves additions, subtractions, and multiplication? Right, everybody? So it's easier to calculate addition, subtraction, and multiplication. And this is good. It's a good approximation if we have like sum functions, like square root, or like exponential function, or like logarithm function. All those functions we cannot calculate by hand. We need our calculator, right? But what if you don't have a calculator? How can you calculate square root of 1.1? How do you calculate e to the 0.15? Right, everybody? So the tangent line can help us to approximate it. So this is a picture. You have the point and you have the tangent line. Do you see if your x is close to a, then your f of x and the L of x, they're very close, right, everybody? And if your x get closer to a, oh, the approximation is even closer and closer. Okay, so this is the big idea. Is imagine we don't have a good calculator, okay? We cannot put square root of 1.1 in our calculator. What can we do? How can we approximate this number by hand? Okay, so write down the steps. Step 1, define the function. In this case, you see, it's square root of some number. So we should define our function f of x be square root of x. Yes, everybody? The number x is like 1.1. We plug in x is 1.1 to this function, then we get square root of 1.1. Right, everybody? So square root of x, this is x to the what power? 1/2, yes. Okay, the first step, we define the function. Okay, next, we want to pick a. Okay, so a here. Okay, so by the way, you can see here, we're putting in x equals 1.1. So a is a good number that is close to the 1.1, and you know what is, okay, and you know how to compute f of a. Okay, what is a good number that is close to 1.1? 1, exactly. Yes, a is 1. Okay, and what is f of a? You plug in square root of 1. What is square root of 1? 1. See, this is a good number. Okay, a good number that is close to our target value, and we know how to compute f of a. Okay, everybody? So how about, okay, more exercise. If I give you square root of 17, and then what is your a? Exactly. If I give you square root of 22, what is a? 21? You know square root of what number? 25. You know square root of 25 is 5. Okay. Yes, without a calculator. So you can find a number near it. Right, 22. Oh, near is 23. We don't know what square root 23 is. 24, we still don't know. But 25, we know. And then if you go down, you have to go down to 16. So obvious 25 is closer to 22 to compare with 16. Right, everybody? How about cube root of 25? What's your a? 27. Exactly. Because you know the cube root of 27 is 3. Okay, everybody? So this is good number. Good number that is close to your x value, and you can calculate f of a without a calculator. Okay, that's a good number. Okay. So that is the first step. Second step, we want to compute the tangent line, right? So we need the derivative. What is the derivative of x? Dylan? What's the derivative of x? The derivative of x to the... Yes. 1/2 x to the minus 1/2. Yes. This is the same as saying This is 1/2. And then because it's negative exponent, it means that factor is in fact in the denominator. Right, everybody? Okay. Now, we want to plug in f prime of a. So a is 1. If we plug in 1 for x, what do we get? We get 1/2. Right, everybody? Yes. So we're looking for the tangent line. And we find that point A is 1. Then we find the derivative to plug in the A. We get the slope, right? And good. Now I have the slope, I have the point. We can use the Poisson form to find the tangent line. So tangent line L of x is now f of a. F of a is what? So we use the formula. What's f of a? 1. Right, everybody? And plus f prime of a. What is f prime of a? 1/2. And then times x minus a, which is 1. Right, everybody? Just leave it like that. Don't need to simplify. Finally, we want to find square root of 1.1. This is f of 1.1. Do you agree, everybody? We're looking for square root of 1.1. And this is f of 1.1. Okay? And now, we can use the tangent line to approximate the function. So this is approximated by L of 1.1. Now we plug in x is 1.1. See, we plug in x is 1.1. And then subtract 1. So what is 1.1 subtract 1? 0.1. What's 0.1 over 2? 1.1 divided by 2 is 0.05. Yes. So we get 1 plus 0.05 is 1.05. Yes, everybody? So this is how we use linear approximation to estimate the value of square root of 1.1. Okay, everybody? See, in this process, do we use a calculator? No. Okay, we can calculate by hand. Now, let's check our work. Okay, the good thing about this type of problem is you can always check your work to see if it makes sense. Okay, could you put this in your calculator? What is square root of 1.1? Could you tell me as many digits as your calculator displays? Thank you. Are they close? Yes, they are close. So then we know, okay, we're doing good. Okay, so this type of problem, you can always know whether you are doing correctly. Okay, look at your answer. Is it close to the true value? If yes, then you're good. Okay. All right. How about more practice? If I ask you to find the function, maybe 11 over key root of 30, what is your function? Okay. If I ask you to approximate this guy. Exactly. 11 have no problem. The problem is cube root of x. We don't know what it is. Right, everybody? And what is dA? Exactly. Very good. Yes, because it's cube root. So cube root of 27, we know what it is. And then you can also plug in f of a. It will be 11/3. Right, everybody? So yeah, you can try this exercise. Okay, so that is example 1. Any questions so far? Good. Okay, so let's continue. Okay, number 2. Use linear approximation to estimate the value of e to the point 2. Okay. First up, what is f of x? How do we define the function? Mackenzie. So e to the point 2. Yes, exactly. Very good. So it's e to the x. And what is a? Exactly. Okay, everybody? The good number is 0. And you know what is f of a? F of 0 is e to the 0, which is 1. See? So 0 is really a good number. We know what is f of 0. Okay. And then the second step, what do we do? Derivative. What's the derivative of e to the x? E to the x. Oh, yes. So when we plug in the a, because it's the same thing, it's still e to the 0, right, everybody? We still have 1. Okay. The third step, what do we do? See, our last problem. Tangent line, yes. Tangent line is what? F of a, which is 1 plus, which is 1 times, what's a? 0, yes. Oh, you see, we get 1 plus x. Yes, here, x minus a. This is a tangent line. Are you okay with the tangent line? So how do you get the tangent line? Point slope form, right? So point slope form. You have the point, you have the slope, point slope form. Y minus the y coordinate of the point equals the slope times x minus a. And you solve for y. So both sides at f of a. Yeah, everybody? So in the exam, I won't provide formula. But you know how to find the tangent line, right? Yes? Okay. So this exam, make sure you review all the derivative formulas. So pattern rule, function rule, chain rule, power rule, exponential function, logarithm function, right? And also this tangent line. Okay. Now, last step. We have e to the point 2. Oh, this is like f of point 2. Okay, everybody? And it's approximated by L of point 2. Do you see we get 1 plus x? We plug in x's point 2. A typical mistake. plug in x's e to the point 2. Think about it. In this whole process, you should not use your calculator. If you have 1 plus e to the point 2, how can you calculate by hand? Right, everybody? So your x is just 0.2. It's not e to the point 2. Is that clear, everybody? So be careful. Be very careful. All right. And also, this is a tangent line. This is a linear function. Linear function means the power of x is 1. Okay, everybody? So another common mistake is students put the slope as e to the x here. No, see, if you get something like this, is this a linear function? No. So the slope should be a number, not a function. You end up getting the tangent line. It's really a line. It's not like other nonlinear function. Okay, everybody? So this is some common mistakes. Okay. 1 plus 0.2 is 1.2. Yes. Okay, now let's check our work. What is e to the 0.2 if you put this in your calculator? Gabby? Thank you. Are they close? Yes. So we're doing right. Okay. So for this type of problems, you can always check your answers. All right, everybody? Okay, so yeah, more exercise. You can try that one. And more exercise. You can try ln of 1.17. Try this. Okay, so this is more exercise. At home, you can try this. Right. All right. By the way, if ln 1.17, what is your a? 1. Yes. ln of 1 is 0. Yes. So the good number is 1. Okay, everybody? So practice more. Okay. So I would say the linear approximation problem might be the easiest problem in this chapter because like related rates, optimization problems, elasticity, right? And this, because you know whether you are doing correctly. You can check with the true value to see if you are doing correctly. So I hope everybody can get this problem correct. Okay, so yeah. Okay, next one. If y equals f of x, where f is differentiable function, then the differential dx is independent variable. The differential dy is then defined in terms of dx by the equation. So we know dy dx is f prime of x. Yes, everybody? It's just different ways to write the derivative. You can also do y prime of x. They all mean the same thing. Yes? Okay, everybody? So the differential form is here, look at this guy. And you both sides multiply by dx. Then do you see you get dy equals f of x, f prime of x times dx? Where we multiply both sides by dx. So this is called the differential form. And now dy depends on f prime of x and the dx. So dy is a dependent variable. It depends on the values of x and the dx. Okay, now we have the picture. Okay, so look at this picture. We have the tangent line. Okay, so this is the tangent line. And we have the dx is here, and we have the dy is there, and Do you still remember slope? Slope is change of y over change of x. Yes, everybody? So the slope, okay. Slope is f prime of x. In this case, is dy over dx. Therefore, it's the rise over run. The rise is dy, the run is dx. Okay, everybody? And then the change of y is the function value. Okay? The change of y, you have 2 points. You have the x, and then this is the x plus change of x. Right? And then your change of y will be the y of the f of x plus change of x minus f of x. Yes, everybody? Okay. And this is change of y. So notice that the approximation, when the change of x is getting close to 0, our change of y is approximately equal to the dy. So therefore, change of y is approximately equal to dy, which is f prime of x times change of x. In this case, dx and change of x are the same. Okay. And this approximation becomes better as change of x becomes smaller. Because if look at this picture, if change of x is smaller, do you see our approximation is better? They're more closer to each other. Okay. So that is differential. How do we solve problems? Here, approximate the change in the y, which is x to the 9th minus 2x plus 1, when x changes from 1 to 1.05. Okay. So it changed from 1 to 1.05. So this is the range of x. Okay? And let's find a good number. What is a good number inside this range? What number do you pick? 1, right? Usually you pick an integer. Okay? Usually you pick an integer. So in here, the integer is 1. So 1 is a good number. Okay. So we look at first step. First step, we compute the derivative. What is the derivative? Down J, what is the derivative? Yes. Good. Everybody okay? This is the derivative. Okay, now we plug in the good number. The good number is 1. Right, everybody? We plug in the good number, which is 1. What happened when we plug in 1? Joseph? Yeah, 9 times 1 minus 2, which is 7. Oh, yes. That's 7. Okay, good. So the formula we're using is this. We want to approximate what is change of y. And it's the derivative times change of x. So step 3 computes the change of x. That is the final value of the x minus the initial value of x. What is the final value of x? Blaine? Yeah, and what is the initial value of x? 1. So what do we get? Yeah, 0.05. Yes, that's change of x. Good. Now use the formula. Change of y is approximately by f prime of 1 times change of x. f prime of 1 is 7. Change of x is 0.05. What's the answer, Dylan? Point 35. Yes. By the way, do you see the x increase? So the change of x is positive because it increased. And your change of y is positive, so it increased. Right, everybody? If sometimes you get your change of y is negative, it means your y increased. Yes. So here we can answer y increases by approximately 0.35. So that's the conclusion. So far, so good, everybody? 4 steps. All right. Let's continue. Part B. Approximate the change in the surface area of a spherical hot air balloon. Hot air balloon. When the radius decreases from 4 meters to 3.9 meters. Okay, so we have the radius is r. Surface area. So surface area, do you remember the formula of surface area for sphere? For sphere. Okay, worksheet. The last class worksheet. Look at the 3D pictures. So for the sphere, we have volume and surface area. Yeah, so surface area is 4 pi r squared. And even though here I don't ask you to find the volume, but volume is what? 4 over 3 pi r cubed. Okay, everybody? And there's a relation between s and e. Can you see when we take the derivative of this? Look at this. Right, the derivative of r cubed is 3r squared. So 3r squared, 3 and 3 cancel. That's why you get 4 pi r squared. Okay, everybody? So that table on the 2D picture, you care about area and perimeter. All the 3-dimensional geometry, you care about volume and surface area. Okay, so make sure you remember those formula. Okay, because you don't know the story problem, what kind of shape I will ask you. Okay, so this is S, right? And we need to find the derivative. So step 1, that's S. And what's the derivative? Paige, what's the derivative of S? 8 pi r. Yes. Okay. Like here, first step, you find the derivative of the function. Yeah, we do that. Second step, we plug in a good number. So look at the range of the radius, 4 to 3.9. What is a good number? 4, yes. We usually pick a integer, right? So let's see. Step 2, s prime of 4 is 8 pi, r is 4. Oh, what's that? What's 8 times 4? 32 pi. Yes. Okay. And step 3, change of r, radius. What is the final value? Downjay, what's the final value of radius? 3.9. What's the initial value? 4. What's 3.9 minus 4? Plus or minus? Minus 0.1. Oh, you see, it decreased. Finally, our change of s, not y, is s, is approximately by s prime of 4 times change of r. Is that okay, everybody? The derivative times change of r. S prime of 4 is 32 pi. We multiply by negative 0.1, so we get negative 3.2 pi. Is that okay, everybody? Negative 3.2 pi. Could you put this in a calculator and give me 3 decimal places? Yeah? Gabby, what do you get? Thank you. Yes. So we can say the surface area increase or decrease? Decreases by approximately what? 10.053. Okay, everybody? So this is the conclusion. 4 steps. Find the function. Okay? Sometimes the formula is monkey, then you familiar with the formula, right? You take the derivative and then plug in the good numbers, you find a number. And then you find the change of r, and then you right? So you really stop. Okay, let's see. Write the approximate change in f of x. Given a small change dx. Okay, in this case, we're not giving a number, change of x. So it's okay. It still computes the derivative. What is the derivative? Blaine, do you know the derivative? Yes, chain rule. This is like you. Yes, good. Okay, so 3 e to the 5x squared plus 2. What's the derivative of 5x squared plus 2? Yeah, very good. Right, everybody? So this is the derivative. Okay, now our change of y is approximately by the derivative times dx. Okay, times dx. In this case, because we don't have number, so just put this inside. Can I combine the 3 and 10 together to get 30? Yes. So I get 30. I can also put the x in front, e to the 5x squared plus 2, and we multiply by dx. By the way, can I move the x here and put x squared times e? No. Dx is not a multiplication. It's change of x. Okay? So your x can be anywhere. Your x could be, okay, let's say it's 0. Your x could be 0, but the change of x is like the change. Okay? And your x could be 100, and then your change of x is 0.5. You know what I'm saying? X and change of x, they are independent. They're totally different things. Your x is like the location of the point. It could be minus a million or positive billion, right? It could be very big, very small. The change of x is the how it changes. Okay, so it could be small, it could be big, but that's totally independent. Okay, so yeah, that is our answer. Any other questions about this session? So I hope all of you can get the problems on this session right. Happy Thanksgiving! Okay, so let's look at our quiz. Alright. Okay, so quiz solution right here. Okay, so the first problem, we have the P of t is the following, right? And you want to add t is between 0 and 20. You want to find the maximums. Remember, maximums is when you take the derivative and you set the derivative equal to 0. Okay, everybody? So you take the derivative. Some of you use quotient rule. Here, do we need quotient rule? Do you see the denominator is a constant? It's not a number. It's not a function, right? Everybody? So in this case, we don't need to use quotient rule because the denominator is a constant. So you can split those two terms. Then you get just polynomial. Then you can just use the power rule. The power rule of t cubed is 3t squared. Derivative of t to the fourth is 4t cubed. And then you simplify, you get this. So yeah, we want to factor it. So I look at the common denominator, also the common factor t squared. So set this equal to 0. We get two roots, 0 or 15. Everybody look at me, especially when you get some mistake on your quiz. Okay? So you get two critical points. And then your domain is from 0 to 20. Draw the picture. Draw the table. See? 0 to 20. 15 is right here. Okay? It's separated into two subintervals. Here, you pick a number. What number do you pick? You can pick what? 1. You can pick 1. See? 1 squared, positive. 15 minus 1, positive. So you get positive, right? And then here, what number do you pick? 16. 16 squared, positive. 15 minus 16, negative. So you get negative. That's why your P increasing, decreasing. This is a maximum. I would say most of you forget to include the table. Okay, everybody? So you lose 0.5 because of the table. And yeah, we verify this is in fact a maximum. So you plug in the P is 15, you get 168.75. Okay, everybody? And then second problem, the elasticity formula is negative P over Q times dQ dt. Okay, everybody? Are you able to memorize this formula? But how I remember is, I know demand is a function of price. So you can take the derivative of demand with respect to the price, and then you multiply by the reciprocal. See? The P, put it upstairs. The Q, put it downstairs. And negative. So this is how I remember it. Okay? You start with the derivative of dq over dt. Multiply by the reciprocal, but the non-derivative, okay, the reciprocal of p and q, and then has the minus 1. So dq over dt, see the negative is negative 1 over p, and so this negative and that negative cancel. The p and p cancel. You get 1 over 10 minus LMP. Find the maximum revenue. Revenue is maximized when E is 1. I also give you the sentence, E is 1. So set the E equals to 1. So both sides multiply by 10 minus L and P. And solve for P. See? Subtract 10 on both sides. And because both sides has negative sign, multiply by negative 1. We get ln P is 9. How do you get rid of the ln? Apply the inverse function, which is E. So E to the ln cancel. You get P. And then here is U e to the 9. Okay, everybody? Let's look at your mistakes. Okay. So here The number is correct. So draw the table. Okay, everybody? So draw the table. And then here, the E is correct. Then you set this equal to 1 and solve for P. Okay? So set this equal to 1. Revenue is maximized when the elasticity is equal to 1. And then here, we don't need to use quotient rule, but if you use quotient rule, that's okay. You plug in 0, and you get this equal to 0. Oh, your t is also 0. And also draw the table. Okay, everybody? Also draw the table. And something wrong when you plug into the t, because this is correct. But maybe when you plug in the calculator, you press some button wrong, incorrectly. Okay. And then here, let's see. Okay, yes. Also use quotient rule, but you realize this is 0, and this is 0, so it's not. Okay, and yes, missing the table. And then set this equal to 1. Don't differentiate. Don't set this equal to 1, and then you find the p. Okay, don't set it to 0. Just set it equal to 1. Okay, everybody? It's not like find the critical point. You don't differentiate and set it equal to 0. You set the E equals to 1. Okay, everybody? That is the maximized value. And then here also miss the table. And see, this is correct. You miss the minus sign and PP cancel. You get 10 minus L and P. Not that. You have this if your P is multiplied, but this is not multiplication, it's subtraction. So you cannot move the 10 up there. Okay, everybody? So be careful. And then here, once you get the P prime, factor it, set it equal to 0, and find the critical point. Okay? And the E, using the minus 1, and so this E is correct. And then, let's see what happens. Yeah, it's E to the 9, not 9 times E, okay? E to the 9. Both sides raised to the power of E, exponent of E. Okay. And then here, 100 prime is 0. See, derivative of a constant is 0. You don't need quotient rule, but you can still use quotient rule, but be careful, the derivative of a constant is 0. So these terms are gone. Okay, everybody? And also the table. Okay, and then here, maximum value, E equals 1. E equals 1. Oh, be careful. L and P. This is not a multiplication, so you cannot divide it by Ln. Ln(P) is a function, it's log of P. So to get rid of the Ln, both sides raised to the power of P. Okay? Do not divide it by Ln. Ln(P) is not a multiplication. Be careful. So I hope you can learn from the mistakes, and then in the exam you won't make the mistake again. Okay, so similarly, 100 prime is 0. So that's why, okay. And also the table, and then yes, set the E equals 1. Okay, everybody? So you know how to do the quiz. So I hope if you have mistake on the quiz, please write down the correction next to your mistake. Okay, so when you review your quiz for the exams, you know what you did wrong. And how about let's also go through the practice exam. Okay, practice exam 4. What type of problems are on it? This one, implicit differentiation. Right, everybody? Implicit differentiation, find the tangent line and the normal line. This one, also implicit differentiation, but you take the derivative with respect to t. Okay? And then this one, we find the derivative. Okay, so you find the derivative. And also this one, you want to find the rate. Okay? It's changing. So this is find the rate of change. Okay. And then here, oh, this is minimize the cost. Okay. So this is optimization problem. You set up the story, draw the picture, and find the relations. Okay. And then this one, elasticity. Yes. Oh, I give you the formula in this problem. Okay. And then here, the differential, right? The things we learned today. But here you need to do quotient rule and chain rule. Okay. Oh, and that's it. So do the practice exam. If you have questions, ask me. Okay. After the break. Yes. Okay. Bye.